Alright, so you have F prime, and F double prime. Y'all remember this little chart that we used to make? Or maybe we made it like one day or something.
Yeah, it's our cheat sheet.
Okay, so plus, minus, up, down, concave up, concave down. And then remember that if F is increasing, then F prime is positive. If F is decreasing, that one's negative. And then up, down. And then remember that if F is concave up, then F double prime is positive, concave down, it's negative. And remember that kind of the usefulness of the chart is that it gives you the relationship between F prime, and F double prime, depending on what you're looking for. Okay? So, first one should be pretty easy because we did one kind of like this in class. Look at it, you have a graph of F prime. Part A says to find where you have a relative minimum. And then part B says to find a relative maximum. So, looking at your graph, where do you have a relative minimum? Where would that happen? -1, very good, that's your minimum. So x equals -1 because F prime changes negative to positive. And then where would our relative maximum be?
There's none.
Oh, there is one. Yeah, -5.
Oh.
Yeah. So -5 would be our relative maximum because F prime changes from plus to minus. And then there's one other critical number that's a neither, and where does that happen?
If it doesn't, so like at 5, right?
At 5, very good. So x equals 5 is a critical number because F prime at 5 is 0, but there's no sign change. So it's a neither. But remember, if it asked you to list all the critical numbers, you would have to include 5, but then say it's not a min or a max. Oh, you do need the test. Okay, alright, last one says, find where F double prime is less than 0. What is F double prime in the graph of F prime?
The slope.
F double prime is the slope. Very good.
Wait, is this graph? Oh, it's an F prime graph.
Yeah, this is F prime. There you go. So if I'm looking at my graph, I want F double prime to be less than 0. That means I want the slope of F prime to be less than 0. So I want it to be decreasing. So looking at your graph, where do we have a decreasing slope?
-7
to -3. And?
Wait, why would it be negative?
Because it has a negative slope on those intervals.
Oh, I was thinking it was like on the negative side.
Gotcha. Okay, now if you wrote this, you would actually not get your point. -3 union and then 2 to 5.
Because these are all that stuff. Like X.
Not because of that. Actually, it's more than that. So you could put because the slope of F prime is less than 0. The problem is with this second interval. Okay, go back and read in the question. What does it say happens at 3? No, read at 3. What does it say happens? You have a vertical tangent. So at that point, at 3, your slope is what? If it's vertical.
It's 0.
Not 0. Undefined. So at this point right here, your slope is undefined. So that means that you cannot include 3 in your interval. So what you would need to do down here in your interval, cross that out, is you'd have to go from 2 to 3 and then from 3 to 5. The only type of point that you have to break it up around is if it's undefined. Because remember, if your slope is undefined, then it's not less than 0 because it doesn't exist.
But wouldn't that still be considered counting 3?
It wouldn't be because it's undefined. If it was a flat spot, it wouldn't matter. So if it was horizontal, nobody cares. Like if it went like this, let's say down and then flat and then it kept going down, that's fine for you to include all together. But if it has a point where it's undefined, you have to break up around that. Okay? Alright, next one. And it's not often that they do stuff like that, but that was why I picked that one. Okay, so next one, we want to find the local max. Where does that happen?
And -2.
Yep, and this is f prime again. So we have a max at -2. Then we would say because f prime changes from plus to minus. So far, so good? Okay, look at part B now. It says find the absolute max and min.
That's the candidate table.
Okay, it is a candidates chart. Okay, however, on this one, do I need to do a candidates chart for the absolute max?
No, you're fine.
Well, I found the relative max. How do I know that it's also the absolute
Oh,
max?
it's the only critical number.
It's the only place where you have a sign change. So, since this is the only relative extrema, did it? Since it's the only one, you know that it's the winner in that category. Okay? So I can say my absolute max is at x equals, what is it, -2? Because it is the only relative extrema. Now, for the absolute minimum, do I have a relative minimum? No. Do I still have an absolute minimum, though? Yes. You would have to, though, check your endpoints. Remember, even if there's not a relative minimum, there can still be an absolute
Let's
minimum.
say we didn't realize about the table, like the graph being like the only max.
So for the absolute max, you don't have to do a table. But for a minimum, you'd have to pick which
Yeah,
end.
let's say that
Okay.
we didn't know that.
Then you would get your point for max, but not for the
So would
minimum
you
one.
be like, okay, so let's say our endpoints are -3 and 4.
Uh-huh.
So would that mean that 3 would be like, how would you know what the value?
Okay, that's a good question. So look at your graph. Between -3 and 4, where is more of the area?
That's what.
Meaning, like, is more of the area above the x-axis or is more of the area below? Okay, do you see how the area up here compared to the area down here, the bottom area is bigger? So remember, the area on top is how much your thing would have gotten bigger. The area on bottom is how much it would have gotten smaller. So when was it smaller, at the beginning or at the end? No, at the end. Okay, so think about, pretend like it's like a particle. It went a little bit forward and then it went a lot backwards. So you would say that your absolute minimum is at x equals 4 because, and then this is how I would explain it, the integral from -3 to 4 of f of x is less than 0 since there is more area below. What's up?
The closer the text.
You're correcting or taking
No,
it for the first time? Okay. And then do you have, if you have your notes and stuff like that, you can use them, okay? Does that make sense?
Yeah.
Okay, now, if you had actual, like, geometric shapes, you could go back and find those, but since we don't here, just stating there's more area on bottom, so you know it ends smaller than it started.
Look at the area.
You'd be looking at the area. Okay, look at the next one. It says to find all possible points of inflection. Okay, points of inflection are where f double prime changes sign,
Find the slope.
and that'd be the slope. So put x's on the graph wherever f double prime, the slope of f prime changes sign. So anywhere that the slope of that graph changes sign, you should put an x. How many are you finding? 3. You should have one here, and one here. So it'd be x equals -1, 1, and 3.
For the test, if you could mark it on the graph.
No. You would just list the points. That would be totally fine. Okay, then the next one says, when is it both concave down and decreasing? Now remember, we don't have the graph of f. We're using f prime to make conclusions. So if I want f to be concave down, what am I looking for in my graph? F prime's slope to be negative. And then if I want it to also be decreasing, then I want f prime to be negative, which is like below the x-axis. Does that make sense? So then on your graph, where are you below and you also have a negative slope?
-2 to 1.
-2 to -1 and
1 to 3.
1 to 3. Good, both of those chunks. -2 to -1, union 1 to 3. Okay, because, and then you would say f prime of x is less than 0 and f double prime of x, which is the slope of f prime, is less than 0. And then make sure to avoid stuff like it, or because it's negative, anything like that, because the graph, just make sure you're being really specific. Okay? Alright, last one for this says, given that f of 1 is 4, find the value of f of 4 and f of -2. Let's do f of 4 first. We want f of 4. What do we have? We have f of 1. So this is going to be a version B. So go ahead and set it up. Your f of 4 equals f of 1 plus the integral from 1 to 4.
Would you do 2 of them?
Yeah, so I'm going to do f of 4 first, and then we'll find f of -2 second. Okay, now, what was f of 1 we said? 4 plus, and then how would we do the integral from 1 to 4?
The area.
The area. Now, look at your graph. We don't know what those shapes are. Go back and reread it. What does it say about the areas? The areas of the regions bounded by the x-axis on the intervals are 9 and 12 respectively. So from -2 to 1, the first one, this is an area of 9. And then on the second one, it says from 1 to 4, it's an area of 12. So should I add 12 to 4?
Yes.
It would be negative, because why? Because it's below. So it'd be 4 minus 12, which would be -8. Okay, set up for f of -2. So you're still doing version B. Our half is still the same, f of 1, but now we're integrating from 1 to -2. What is that going to change for my area? Which pocket are we doing? Not the 12, but the 9, and it's below, so it would be negative. It's positive because why? It's negative and it's backwards, and so then those cross each other out. So your area is below and it's backwards, so that's what makes it positive. Makes sense? So that'd be 13. Good? Alright, next one. Okay, alright, go ahead and read through that. It tells you more stuff about the areas. Go ahead and label them in your graph. Okay, I'll read it to you as you're reading it. It says, a particle moves on the x-axis so that its velocity for 0 to 6 is given by the differentiable function shown above. The velocity is 0, at 3, and at 5. So it's telling you the x-intercepts there. The graph has horizontal tangents at 1 and at 4. The area of the regions bounded by the t-axis in the graph of V from 0 to 3, 3 to 5, and 5 to 6 are, this one is 8, the next one is 3, and the last one, which cuts off at 6, is 2. Okay, part A. Find both the time and the position of the particle when it is farthest to the left. Is that a max or a min if I want to be farthest to the left? That's a minimum. Now, if they're going to want the position and the time, I would go ahead and just make a chart. So, where do I have a relative minimum?
That
At 3. Good. How do we know it's 3? Because it changes which direction? Negative to positive. Very good. So I have a relative minimum at t equals 3. What are the endpoints that I have to also check? 0 and 6. Yep, 0 and 6. Now question. 3 is the only relative minimum. Do I have to make a chart? Yes. Because not only is there a relative minimum, what else is there? A relative maximum. If there's more than one, then you have to do the chart. You can't just decide who wins. So I don't have to put 5 in the chart because I know it's a max, but that busts that theorem that if there's only one, you can conclude who's the winner. So 0, 3, and 6 are my time values. What is the position at 0? It said it in the question. At time 0, the particle is at -2. That's my starting point. So at -2 to 3, all of my area was accumulated below the x-axis. So do I add or subtract 8? Subtract 8. Where would I be at 3? -10. Okay, and then I'm going to squeeze my 5 in here because it did change direction, even though I know 5 is not going to win. So from 3 to 5, it went forward 3. Where would it be then?
Forward 3,
-7. -7. And then from 5 to 6, it went backwards 2 more. That puts it at -9. So when is our particle farthest to the left? At 3, and the farthest to the left it goes is -10. So it says to find both, so we would say the absolute min is -10 at t equals 3. And if you show a good chart, you don't have to do a bunch of extra explaining. Now, question, why would my chart not be good? No, not because of that. That's okay.
Label it.
Has to be labeled. So make sure if this is a position chart, you need to label it time and then position. Okay? Next one says, for how many values is the particle at -8? How many times does it have to go through -8? Okay, it would have to hit here because -8 goes between -2 and -10. Does it have to hit -8 again here?
Yes.
And what about here?
Yes.
Yes, so how many times altogether?
3.
3. What theorem says that? 3 times. IVT guarantees this. Because, what type of function is v, it said?
Differential.
And if it's differentiable, what is it? Continuous. Because v is continuous and -8 is between x of 0 and x of 3, x of 3 and x of 5, and it's between x of 5 and x of 6. So you're saying it's sandwiched between these two, those two, and those two. And if you could say that shorter than I said it, I'm not always the best about making things really short. But you would want to state it's continuous and that -8 is between 3 different times. Okay, next one, C. Is the speed of the particle increasing or decreasing from 2 to 3? Highlight that section of your graph or maybe like squiggle it or something. Okay, 2 to 3 is here. Okay, what is the sign of velocity for that section? Velocity is the graph we're looking at. Is the graph positive or negative at that section? It's negative because it's below. So my velocity is negative. What is positive about the graph though? The slope. And what is the slope in terms of like position and velocity? The slope is the acceleration, right? That's the second derivative. And if my acceleration is positive, but my velocity was negative, then what would that be for your speed? Decreasing, because they're opposite signs. Now, y'all know I teach at those Saturday things. One of the kids said that their teacher explained that your velocity is getting closer to 0 And that kind of makes sense too, right? If your graph is getting closer to 0, then it would be slowing down.
Oh, yeah.
So that kind of makes sense too. But either way that you think about it, it doesn't matter. Okay, so I would put speed is decreasing because v of t is less than 0, and then I'm going to put below the x-axis, because remember that was our graph, but a of t, the slope of v of t, is greater than 0. And because those are opposite signs, those conflict with each other, so that means it's going to slow it down. Okay, last question says, during what time interval, if any, is the acceleration of the particle negative? Acceleration is what in the graph of v?
Derivative, slope.
Yep, the slope of v of t. And so I want the slope of my v of t graph to be negative. Where does that happen? What intervals?
Wait, I want the slope to be negative, so 0 to 1,
Okay, 0 to 1 union, where else?
5 to 6.
Now, the slope is actually negative
No.
starting at 4, right?
4 to 6.
So 4 to 6. And then because a of t, the slope of v, is less than 0. Okay? Bye. Now, one other thing I do want to point out is, how did you know to stop the graph at 1 instead of at 2?
Because it goes flat and then it goes back to
Yeah, and it tells you right here that the horizontal tangents happen at 1 and at 2. So that means that here and, where was the other one? And at 4. Okay, that tells you that that's where it changes from negative to positive or vice versa. Okay? Good job. All right, next one. All right, some of this is the same, but a little bit of it's different. Actually, we did this one in class today, huh?
Yeah.
Okay, we did that one. Actually, we didn't do A, but we did do B. A says to write the equation for the tangent line for F.
Oh, the last one was G.
Yeah, the last one was for G. So if this is my graph of F, what is my ordered pair that they gave us? 1, 2. So your point would be 1, 2, and then your slope you would have to pull from the chart. So if I want f prime of 1, and that's a graph of f prime, what would it be? It would be negative 4. Good. And then from there you do y minus 2, negative 4, x minus 1. Now that part, again, we did in class today, so we can skip that. Okay, next one says, find a relative extrema. How many relative extrema are there in the graph?
1,
Only one?
2.
2. One here and one here. Which one is negative 1?
Max.
Okay. X equals negative 1 is a relative max. I'm going to put relative / local maximum just to make sure that you guys remember both words. That would be because f prime changes plus to minus. And then x equals 3 would be a what? A relative or local minimum. Because f prime changes negative to positive. Next one says point of inflection. There is only one point of inflection on the graph. Where does that happen at?
2.
At 2. And then you would say because your slope changes from negative to positive.
Oh, never mind.
Okay? Now there's almost one here because your slope is 0, but then since it goes from a negative to a negative, that doesn't count. So x equals 2. You have a point of inflection because f double prime of x, the slope of f prime, changes sign. And remember, for a point of inflection, it doesn't matter which way it changes sign. As long as it changes, you're good. Okay, letter E. It is very rare that they make you sketch these, but when they do, it pretty much always is kind of hard. So we are going to practice it here. What I want you to do is, I'm going to do it up here at the top. We're going to set up a double line chart. So let's do F first, and then F prime first, and F double prime second. Okay, first F prime. What were our critical numbers? We already found them earlier. Okay, -1 and 3. And how did f prime, which is our y values, how did those change? They went from plus to negative to plus, right? So plus, minus, plus. What does that mean that f did? It went from increasing, decreasing, increasing. Remember, those are your y values. Okay, then the other thing that we need to check is f double prime. That was your point of inflection. Where did our point of inflection happen at? 2. So I'm going to put 2 right here. And then remember, we're looking at our slope for this characteristic. So my slope was negative all the way through, and then positive. Concave down, and then concave up. Very good. Now, the one other thing you have to be careful about when you do your sketch is that if they give you a point, you have to hit that point. So when they tell me that f of 1 is 2, on my graph, when I sketch it, I need to make sure at 1 that I'm at 2. Nothing else really matters, but that one point, you have to hit it. Okay? Then at -1, I know that I'm going to have a max. And at 3, I need to make sure that I have a min. And then what I would do from there is kind of cut your graph off, kind of cut your graph up, and just go piece by piece. So for my first section, from here to here, my graph needs to be increasing and concave down. So we'll maybe do it like that. Okay, then at -1, what happens? I'm going to be decreasing, but still concave down. Actually, I probably need to make this go higher. And then what happens at 2? Wait, hold on. Why is my graph so far back? Let's make -1 right here. So it's going to go from -1.2, so it's going to go up until -1. And then from -1 until 2, it's going to go down, and it's going to be concave down. So it'll need to be kind of like that. And it needs to continue doing that all the way until 2. Then at 2, what happens? My graph is still decreasing, but it's concave up now. So at 2, I need to switch. And then at 3, what's going to happen? It's going to still be concave up, but now it's going to be increasing. So it would be like that. And then what you can do is go back and double check. You should have a maximum at -1. We do. We should have a minimum at 3. We do. And then my graph changes from concave down to concave up at 2, which is right here. Down and then up. So we know that we did it right. And we hit that one point. Remember, that one point that they give you, you do have to hit. Does that make sense? Okay. Alright, next one. Okay, there's one just like this actually on your homework. If f prime is greater than 0, what does that tell us about our function? Should it be increasing or decreasing? Increasing. And then what about if f double prime is less than 0? What does that mean?
Concave up. Or down, sorry.
Concave down. So first thing that I want you to do is eliminate any charts that are not increasing in their y values. Which ones can we cross out?
C.
Yep, C. Okay, because I can see that my graph is decreasing there. Okay, now if it's increasing but it's concave down, should your graph be getting steeper or flatter? Flatter. So look at your jumps each time. From 7 to 9, how many is that? 2. 9 to 11, that's
3.
still 2. And then 11 to 13, that's still 2. So is that slowing down? No, that would be linear, right? It jumped by 2 every single time. Okay, look at this one. 7 to 10, that was plus 3. 10 to 12, that's plus 2. 12 to 13, that's plus 1. Did that get flatter? And it's going to be that one. Okay, read through the next one. See if you can do the next one. It's very similar to that, just kind of set up differently. Okay, so if f prime is less than 0, are we increasing or decreasing? Decreasing. And then if f double prime is less than 0, we're concave down. So, right, because it says less than 0. So what I'm going to do now is make a chart. I just think it's easier in chart form. So 2 and 17 are partners, and then 3 and 14 are partners. Then it says what could be the value of 4. So we want to know what would have to go there. First question, can it be 20 if my function is decreasing? No. Can it be 13? Well, let's think about how many did it go down from 17 to 14? Minus 3. And if I'm decreasing and I'm concave down, should I be speeding up or slowing down? Speeding up. Because they're both negative. Remember that when they're the same sign, you're going to be going faster. So I have to go down at least 3 more. So if I put a 13 here, that would only be down 1. That's not going to work. What about if I did 11? That would be down 3. That's the same amount. That's not going to work. But if I did 10, that would be down 4, and that's getting steeper. So it'd have to be that one. Make sense? All right, next one. Okay, we need a calculator for these. Blast. Do y'all have calculators? Okay, if not, I'll happily go get you one. Okay, go ahead and type your equation in. And then we're just going to practice finding those. Oh, yep. So actually now question, if we want to find local extrema, what do we want the graph of? F prime. So we need to find f prime of x first. If my function was cosine 2x, what's the derivative of that?
Negative sine 2x times 2.
Okay, so it'd be sine 2x negative, and then times by 2. What about the derivative of ln 3x?
1 over 3.
1 over 3x times 3. And then if you have 3's on top and on bottom, those can cross out, right? So I'm going to rewrite this as negative 2 sine 2x plus, and then just 1 over x. Because those 3's cross out. Okay, so graph that in the calculator. And then if we want a relative extrema, we're looking for our graph to do what?
Go from relative extremes to either.
So we want it in the graph, though, to cross the x-axis, yeah?
Yeah.
Okay, so here's my graph right here. Okay, then I'm going to hit second trace is how you find it. Go ahead and actually find that point. So remember, we want to find the x-intercept in the graph. So it goes like this, down, up, down, blah, blah, blah. And we're just finding it looks like the first one right here. And y'all know how to find that? Second trace 0 is your choice, number 2. And then you would go a little bit to the left, and then a little bit to the right. Oh yeah, that would make it a little bit easier. 0 to 1. And then we'll see less of all the extra stuff. Okay? You can also, like, I really suck at making multiple choice, but they wouldn't give you an answer that's so close that you could just guess it. You'd have to actually find it. So second trace, then we want our 0. Go a little bit above, a little bit below. And that would be 0.577. Is that a relative max or a relative min based on how it changes sign? Max, good. Okay, look at the next one. It says, when does it change concavity? What would have to change sign in the graph for you to have a change in concavity? Yep, this is f prime, so remember that would be your slope. So do we remember how to find that point? Okay, I'm going to change my window back just to be normal so that I can find kind of like the lower point. So you'd hit second trace, and then if I want this point right here, I'm going to choose the minimum in the graph, which is option 3. So I'm going to hit minimum, option 3. And then remember that when you do that for your left bound, you have to go a little bit to the left of that point. So I'm going to maybe go like right here. And then I'll put my right bound on the other side of the bottom of that hump. So I put my left here on this side and my right over here on this side. And then it's 0.931, which is option, second letter B. It never gets better. Okay, then number 3. For the same function, find f of 2, given that f of 2 is 4.5, find the value of f of 6. What would we be doing there? Version B. Version B. Okay, you would have capital F of 6 equals. Then you would have capital F of 2 plus. And then the integral from 2 to 6. And then make sure when you set up your integral, you would want to make sure you're using 2 and 6 as your endpoints. Yeah? Then you already have it typed into your calculator. What is capital F of 2? 4.5 plus. And then here you would use math 9. Yeah? Okay, now actually let me ask you a question real quick. I'm not going to make you find it. But what should you be integrating here? F prime should be F. Because remember that these can only be one step away. So if this is a capital F, you need to be using normal F, not F prime. Okay, last one, number 4. If you want F double prime at 4, what would that be? What would you need to do in the calculator? Can do
dydx.
Yep, second trace, and then if you do option 6, that's the derivative. You could also use math 8, it doesn't matter. Either one of those would be good. But if this is f prime, then you would be doing it at 4. And actually in the graph it's pretty fast. So 0.5194. And you would be using the dy dx feature in the graph. Make sense? Alright, so the last ones left are just for you to practice on your own for fun. And then you can check your answers whenever you want. Good job.